In this example, we want to determine which function represented by a table is linear. We're still looking for ratios, proportional relationships, but we're looking at it in a different way. Now we're looking to see how x compares and how y compares. So if we look here, x compares from 1 to 2 is 1, and from 2 to 3 is 1, and from 3 to 4 is 1. Then we look at the y comparison. And y from 6 to 8 is 2, 8 to 10 is 2, and 10 to 14 is 4. So now I'm going to compare 1 to 2, 1 to 2, and 1 to 4. So I have 1 over 2, 1 over 2, and 1 over 4. And if you look, these are not the same, so it's not a linear comparison. In the same light, we look at the next example. So from 2 to 1, you're subtracting 1. From 1 to negative 1, you're subtracting 2. And from negative 1 to negative 4, you're subtracting 3. Now, because these are different, don't think that it's not a linear function, because it still can be. Now we have to look at the y. So from negative 6 to negative 3, we're adding 3. And from negative 3 to positive 3, we're adding 6. And from positive 3 to positive 9, we're adding 9. Now, once again, we must compare the negative 1 to positive 3, negative 2 to positive 6, and negative 3 to positive 9. So let's write those ratios. We have negative 1 over 3. And we have negative 2 over 6, and we have negative 3 over 9. And if we look closely, we'll see this is reduced to negative 1/3, this reduces to negative 1/3, and this reduces to negative 1/3. So yes, this is a linear relationship. Next, we want to define two vocabulary words, so make sure you write these down. We have discrete data and we have continuous data. Discrete data means things that you can count. All right, so for example, they could be people, they could be cars, and they're things that you can't have half of. So they must be whole. Oops, that T looks awful. So we're going to say they must be whole. So you can't have a half a puppy. That would be discrete. Continuous means you can have part of them. So you're talking about like an hour. You can have part of an hour. You could have 10 minutes. You could have money. You could have part of $1. You could have 25 cents. So anything that you can have part of is continuous. Discrete is anything that you can't. So a discrete graph, if you're just doing, if you're graphing a discrete graph, we graph that with a dotted line or dashed line. And a continuous graph is a solid line. So remember that this is a solid line graph. This is a dashed graph. Looking at this example, it says a gallon of milk costs $2.59. The total cost of G gallons of milk is a function of the price of 1 gallon. Make a table and graph the function. So look at this. We first have to decide, is it discrete or is it continuous? Well, since you cannot buy a part of a gallon, you have to buy the gallon, we're going to make this a discrete graph. So this is going to be discrete. And I know you're going to say, well, you can have a half a gallon of milk, but it's a different type of container. You can't take the big plastic container and say, I'll take just half of that. You have to buy the whole container. So we want to come up with a table of values. So we're not going to have any negatives because you can't buy a negative gallon of milk, and we're not worried about a 0 either. So we're going to start off with 1 gallon of milk, and this is going to be my gallons. and then we're going to talk about the cost. So 1 gallon of milk costs $2.59. Then I'm going to do 2 gallons of milk, which is $5.18, just $2.59 times 2. 3 gallons of milk is $7.77, and 4 gallons of milk is $10.36. So now I want to graph this, and I'm going to put my number of gallons down here, and over here I'm going to do my total cost, and that's going to be in dollars. Now yours is going to look much better than mine, because yours is going to be neater. This is a little cumbersome graphing on one of these. So for 1 gallon of milk is $2.59. So I'm going to make each one of these lines 1 gallon. So 1 gallon of milk is $2.59. 2 gallons milk is $5.18, so about there. 3 gallons is $7.77, so almost 8. 1, 2, 3, 4, 5, 6, 7, almost 8. And 4 gallons is $10.36. There. And then I'm just going to put a dash mark there for mine. And make sure you're using a ruler. The function C equals 15T represents the cost in dollars of T adult tickets to a museum. Make a table to graph the function. So if we look at this, we're going to make a table, and T is going to be the adult tickets to the movie, and our cost is dependent on the number of tickets, so the cost is the dependent variable. So 1 ticket costs $15, 2 tickets cost $30, 3 tickets cost $45, and 4 tickets cost $60. Now, there's no negative numbers because I can't order negative tickets, and I really don't care how much 0 tickets cost because I'm not buying them. Now I need to graph these, so I'm going to go ahead and set up my axes. So down here is going to be my tickets, and I'm going to squeeze that on here because it's really tight. And then over here is going to be my cost in dollars. And again, I'm going to use these darker lines here for my tickets, so my graph looks a little bit better. Now, I have to determine, is this going to be a discrete graph or a continuous graph? Well, I can't buy half a ticket, so that makes it discrete. So 1 ticket costs 15, and since I don't have 15 on here, I'm going to make, let's see, 5, 10, 15, 20, 25, 30. That's not going to work, so I'm going to make them each worth 10. So 1 is going to be 1, and 15 is about in between there. 2 is going to be 2 and 30, so 20, 30 in between. 3 is going to be 45, so 20, 30, wait a second, 10, 20, sorry, 10, 20, 30 would be here, and then 3, 45 would be 45, and 4 would be 60, 50, 60. And again, this is going to be a dotted line. And your lines should be straight, and they should follow the ruler if you craft them correctly. Looking at this one, it says Lisa lifted weights and burned 100 calories. Then she walked and burned 257 calories per hour. The function C equals 257 times the number of hours plus 100 gives the total calories Lisa burned, where C represents the calories and H represents the hours walking. Use the equation to make a table and graph the function. So we're going to start there. This is my equation. and we're going to use it to make a function. It says Lisa can walk for part of an hour, so the data is going to be continuous. Plot the data and connect the data points with a solid line. So because this is a continuous graph, we are going to use a solid line. Now I'm going to move on to graph it because I don't have room on here. And my equation was C equals 257H plus 100. So I need to set up my graph here. I'm going to do my time down here at the bottom, like I always do. And my calories over here. Now I need to come up with some data points. So looking at I'm going to make a table, and this is going to be my H and my C. So in 1 hour, in 0 hours, if she doesn't work out at 0 hours, she still will have burned 100 calories because she walked. Because she lifted weights. So no matter what, she's going to burn 100 calories. If she walks an hour in addition to that, then she burns 357 calories. If she walks 2 hours in addition to that, she burns 614 calories. And if she walks 3 hours in addition to that, she burns 871 calories. So now we're going to graph her calories burned. So because my numbers go from 100 to 871, I'm obviously not going to be counting by ones. So I'm going to look here for a minute. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So I think I'm going to go by, I think I'm going to go by 50. So this will be 100. 152, 253, 354, 455, 556, 657, 750. Yes, that's what I'm going to do. And again, like I did last time, I'm going to do every third one here is going to be 1. So in 0 hours, she's going to burn 100 calories. So that's my first point. In 1 hour, she's going to burn 357. So 50, 100, 152, 253, 350, a little bit higher than 350. And in 2, she's going to do 6. So 1, 2, 3, 4, 5, 614. And then in 3 hours, she's going to do 871. So she's going to graph that one. And this is continuous, so I'm going to draw a line, and it should be perfectly straight.